Hi friends. So today we're going to look at problem 322 on LeetCode. It's called coin change. It's a medium level problem. It's pretty like problem 4514 likes to this problem. It's medium level and it seems like it's asked by a few companies like Amazon, Bloomberg, Google, Apple, Microsoft, etc. So it's a pretty common problem. And I believe if you understand the logic, it's probably more of an easy medium than an actual medium. So what's the problem statement? The problem statement says you're given coins of different denominations and a total amount of money amount. You need to write a function to compute the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by a combination of the coins, you return a -1. So here's an example. You're given coins denominations 1, 2, and 5. The amount that you're looking for is 11. The expected output is 3 because you can take 3 coins, 2 coins of 5 denomination, and 1 coin of 1 to make 11. So as always, I'm going to use some visuals to illustrate the logic behind the approach. You can always use your own language of choice to write the algorithm. I'm going to also, in the end, go through a quick Java code representation to explain it. So here's what we'll do. Here's 3 coins that we've given, right? It's 1, 3, and 5. The amount that you need to make is 10. So what we do is we define size. That's going to be amount plus 1 because remember, if you're using an array, it's always 0 based. So that's why you take an additional number, add it to the amount that we need, which is 11, and then just visualize the amount as going all the way from $0 to $11, right? Because that's the amount that you need to get to. So the idea here being, since we need to solve the problem for the given amount, let's solve it for each smaller amount and then keep building on top of it. So this kind of approach is called dynamic programming. So we're going to use that same approach. So let's build out an output array. So here's our output array, which is going to be size 11. And what this represents is for each dollar amount, this will represent the minimum number of coins to make up that particular dollar amount. So we go through and build out each of these, and in the end, we will have built out the minimum number of coins required for the amount. So let's start with, in this case, let's start with 0. So what we do is we initialize dp0 to 0. That's going to be our start because 0 coins can make up amount 0. Now starting with $1, what we do is for each of these dollars amount, we take all these coins one at a time. And then what do we do? If that coin amount is less than the amount that we're trying to make, we can take that coin. And if we take that coin, then we subtract the amount of that coin from this dollar amount and then take the minimum number or the DP for that amount. So as I go through this, it'll be a little bit more self-explanatory. So let's take $1. Now, can we take this coin? Is it equal to or less than this denomination? It is, so we can take it. If we take that, that's coin 1. And then what's the remaining amount? So if you subtract 1 from 1, it's 0. What is DP of 0? It's 0. So we do 0 plus this 1 coin that we already took. So the DP for $1 is going to be 1. Same thing for $2. Can we take $1? Yep, we can because it's less than 2. If you take this 1, you subtract 1 from 2, and we're left with $1. What's the DP of 1? It's 1. So the minimum number of coins required to make $2 is going to be 1, which is $1, plus dp of 1, which is 1, so that's going to be 2. Can we take $3 for this? No, because it's greater than 2, and same for $5. So the dp for $2 is going to be 2. Now for $3, can we take this? Yes, because it's less than or equal to 3. So it's going to be 1 because you took this coin, and then subtract 1 from 3, it's going to be 2. What's the dp of 2? It's 2. So you add 2 to 1 because 1 is the coin that you took. So the minimum is 3 so far. Now can you take $3? Yes, you can because it's equal to or less than 3. So if you take this coin, you do 1 for that coin, and then what's remaining is 3 minus 3 is 0. So dp of 0 is 0. Now you just had to take one coin in this case, and that's less than the 3 before, so that's our min. So dp of 3 is 1. Now similarly, we build out all the way to 5, and I'll take another example. Let's take 6. Can you take the $1 denomination? Yes, you can, because it's less than or equal to 6. Now subtract 1 from 6, it gives you 5. What is the dp of 5? It's 1. So you take this 1 and the 1 for the coin that you took, so the dp of 6 is 2. So you use that and you build all the way up to 10. And then finally, when you look at $11, how do you build it out? So $11 is going to be, let's take each of these denominations. Let's take 1 first. Can you take it? Yes, it's less than or equal to 11. Subtract 1 from 11, it's going to be 10. So what's the dp is going to be 2, which is dp of 10, plus 1 for the coin that you took. So that's going to be 3. Can you take 3? Yes, you can, because it's less than or equal to 11. What's 11 minus 3 is 8. So the dp is going to be 2, which is the dp of 8, plus the one coin that you took. It's still 3, and it's going to be the same thing for 5 as well, because you can take 5, it's less than or equal to 11. 11 minus 5 is 6. dp of 6 is 2. So you take 2 plus 1 for the coin that you took. So finally, dp of 11 is 3. So hopefully this visualization and illustration helps you understand how we built all the way from 0 up to the denomination that we're looking for. So going back to our actual problem in a little bit of code on how to do this. So if you remember, what we did was max would be the amount plus 1, right? And then this is our dp array that we built out, which is essentially it's a new integer. The size is going to be max, which is amount plus 1. In this case, it's going to be 11 plus 1, 12. What we also do is initially fill out the array with the maximum amount. We do this for essentially this one for this use case, and also because we do a min, we always try to get the minimum number of value. So you could fill this out with max, or you could fill it out with a random high number. It could even be integer max value. And as you remember, we started dp0 was 0. Now this basically is the loop that does the whole logic, which was, remember, we go for value 1 all the way to amount. Remember how we went from 1 to 11. And then for each of those values, we go through each of the available coins, which is 1, 2, and 5, and then see if that coin value is less than or equal to the amount that we're trying to build. If it is, then we take that coin, which is 1, and then take the dp of the current value minus the coin value, and then try to compare it with the current dp that we have, and do the min of those. So once we're done with this loop, we reach the end of our amount. And then all we have to do is we have to see the dp of amount, which in this case, it's going to be dp of 11. Is that greater than 11? Right? Or dp of 10 is greater than amount. remember we filled our array with max initially, which was more than amount. So if it is, then we just return -1. That means we couldn't make this amount with any of the coins available. Otherwise, we simply return the DP amount. So hopefully this was, a pretty easy medium kind of level problem. Hopefully the illustrations helped explain the logic. And hopefully if you see this next time in your interview, you should be able to kind of remember the illustration to be able to write down your own code. Again, if you like this video, please do like my channel. I hope to continue making more content. Thank you.